So hello everybody, good day to all. So I am Dr. Sharmistha Ghosh and I am presenting you Vector Algebra, the module 6 of your bridge course on mathematics. Now you have learned Vector Algebra in your class 2 level. So why do we need to look into this again? The reason is just to review the concepts which you have already learned and clear your doubts if you had any, and brush up the entire thing so that you can have a better understanding of engineering mathematics as you start your first semester course. Okay, so what is vector algebra all about? So as the name vector is there, so of course we will be talking about vectors or vector quantities and then algebra of vectors. Now, so what are vectors or vector quantities? But as we pose this question, what are vectors, another term comes in, and I hope everybody can guess that, whoever is attending this lecture. What is that? That is scalar. Actually, when we talk about physical objects or physical quantities, the quantities can always be classified into two groups. One is scalar and the other is vector. So we will see both these terms parallelly side by side, and of course we start with scalars. So what are scalars or scalar quantities? These are some quantities which are characterized by their magnitudes only without any reference to direction. So what are some scalar quantities we can remember? I think everybody can remember, but let us see some examples over here. So time, temperature, mass, density, distance, speed. These are some common examples of scalar quantities, and there are many more. Say why these are scalar? Let us take any one of them, say temperature. And I say that temperature of Kolkata today is 33 degrees centigrade. Temperature of Kolkata yesterday was 34 degrees centigrade. Or we have a prediction for tomorrow that the temperature will rise to 35.6 degrees centigrade. See, in all this data, some numbers are coming. There is no sense of direction associated, but only some numbers are coming. And of course, yes, what is there along with the numbers is a unit of measurement or the scale of measurement. Instead of centigrade, if I would have taken the unit as Fahrenheit, then of course the numbers will change. So your answer to what is today's temperature is dependent of course on the unit of measurement or the scale of measurement. In fact, to this fact only, this name scalars or scalar quantity, this word scalar owes its name to this fact, scale of measurement. But anyway, we can easily understand that there is no concept of direction associated. Okay, and now actually real numbers, a real number is a scalar because again it's just a number, there is no direction associated, and in fact a real number represents any scalar. Okay, let us now come to vectors. So what are vectors or vector quantities? I think we can now remember that vector quantities are the quantities which involve both magnitude and a sense of direction. So what are the examples we can remember? See, some of this what I have cited here are displacement, velocity, acceleration, force, electric current. I think all these terms you have heard in mathematics or in your physics courses. So these are all vector quantities because not only a magnitude, direction is also associated with these. We will see little bit more closely with a particular example. And before we go to the next example, one thing we just try to remember that a vector is represented by a directed line segment, because we have told, of course, that vector has a sense of direction associated with it, and so we need a directed line to show the direction. Okay, so before we come to the representation of the vectors with directed line segments and so on, we just want to take one example and to clear our sense of the difference between the scalar and the vector. So we do so using an example, and where we actually see the difference between distance and displacement. Now see, this is a water body, say this blue one, and suppose we want to go from the point A to the point B. Now here we have shown here two paths. Now suppose that because this is a water body, I am not allowed to cross directly, so I have to take this roundabout path along the side of the lake. So we can measure the distance covered along this path. Maybe say it is 10 kilometers. I have to walk 10 kilometers if I want to reach the point B from A along this path. But see, it's just the distance, this 10, the number is there. It's not possible to associate a direction, specific direction, because actually at each point the direction is changing. However, in case we were allowed to go straight, maybe we could go via a boat or something along this straight line AB, then it just gives us the actual displacement from the starting point A to the starting point B. So this is what, now see, of course this has a direction associated with it. So therefore we can see easily that the distance is a scalar quantity where there is no direction associated, and this is displacement is a vector quantity where the direction is associated. Now in this way we can have numerous examples and compare the difference between scalar and vectors. Say one more to consider, speed, which is the rate of change of distance with time, that is your that is a scalar quantity, because distance is a scalar, whereas this velocity, this is rate of change of displacement with time, so of course that is a vector quantity. Okay, so after having understanding the difference between a scalar and a vector, let us now see that how do we represent vectors. Now of course, because vectors, they have associated with them magnitude as well as direction, we of course need some coordinate system. So let us first look into a two-dimensional Cartesian coordinate system, which I think we all know from our school level knowledge, but still let us look into it once more closely. So here we have this two-dimensional rectangular Cartesian coordinate system given by the two coordinate axes. Here is the x-axis and this is the y-axis, which are at right angles to each other, and so this divides the xy plane or the two-dimensional plane into four quadrants, and as per the normal nomenclature, this is quadrant 1, 2, 3 and 4. And the total angle covered here is starting from 0 degree, it comes to 90, 180, 270 and again comes back at 360 degree. And if the directions conventions are noticed, this is north, south, east and west. So this is our conventional rectangular Cartesian coordinate system. And now one thing, let us observe that, say from a layman standpoint, if I'm at a point and I want to move, what are my options? If I want to go via a straight line, it can be either to the left or to the right or up or maybe in front, and back or in down. So you see this left, right, up and down, these 4 directions are only covered in your rectangular Cartesian coordinate system. Okay, and now how do you represent a vector in terms of this coordinate system? For that, let us see some examples. As we have already told that vectors are represented by directed straight lines, so it is so, as we can see here. This example, we can see this is a vector, a directed line whose length you can see is 30 meters measured on a 10 meter scale, and the angle is 90 degree. Why? If you remember, you see this is the vertical line, so this is the angle is 90 degree. Similarly, if we had a vector along the x-axis, then it will have an angle 0 degree. If we have something in between, say this can be a vector of angle 45 degree. So that is what is depicted in the next picture. So this is a vector at angle 0 degree and its length is 50 meters, 5 units of length, and this is a vector of 30 meters length at an angle 45 degree. So I hope we are very much clear that how we represent vectors. And now how do we denote these vectors? When we will use them in problems, we need to have some nomenclature. So the normal nomenclature is, we will show the vector like this. If A is the initial point or the starting point and B is the end point or the terminal point, so we have a directed line like this. And how do we write it? We actually write this vector taking us from the point A to B as AB in bold letters or AB with a small vector sign up. And another notation is also possible, that the vector AB we just represent by a single letter A. So in that case we will write the vector as A in bold or A with a small arrow or a small vector notation. Okay, so this is how we represent a vector with respect to a 2-dimensional coordinate system. Now of course, actually we are in space which is 3-dimensional. So actually we would need to see the representation of vectors also in a 3-dimensional coordinate system. But yes, that is going to be a little bit more complicated than the 2-dimensional case. And so we will cover up that in our next lecture, as this was our just preliminary and very much introductory lecture. So we will stop here and continue in the next class. So thank you very much for your kind attention.